All right. My name is Oscar Salvador. I work at the SUSE Labs department on the kernel core team. And today I would like to talk about how to, what the ongoing effort that for HugeTLB to be integrated into the generic pagewalk infrastructure that we currently have. So that's a bit of the agenda. It's the background, what has been done so far, the future plan, the current API, and I show you also the new API, how is the process going, and possible potential next steps that we might take. So the background is that last year at LSFMM, Peter Xu from Red Hat gave a talk about how we could further integrate HugeTLB into the core, so the generic core. The reason for that is that lately, for the past 2 or 3 years, there have been some people trying to add new features in the HugeTLB code, but it was rejected because the code itself is already quite complex and yeah, it's convoluted. So those features were declined. And it was brought to LSFMM that what could be done to ease that and be able to add new features in the future. So yeah. So for the last year, there have been some patches that made HugeTLB go through generic channels instead of going through their own. For instance, the HugeTLB integration into the generic get user pages interface. For the Arch get the map area functions when you're trying to map stuff and so on. And one of the most important stuff was the last one. It was the conversion of huge page directory on PowerPC from huge page directory to the normal page table works, because prior to that, yeah, it was quite a special case. And one of the proposed goals was to integrate HugeTLB into the generic pagewalk, which will reduce substantially the places we have to special case HugeTLB, and it will also help in removing a lot of duplicated code. So this is kind of the current API we have. So as you can see, we have the entry function, the world page range, and then we check whether that's a HugeTLB BMA or not. And if it is, we just go straight to some specific HugeTLB functions. And if not, we'll walk the page table as usual. We'll call walk pd, then p4d till we reach the PTL levels. And that's on the right side, we have the struct with the indirect callbacks. As you can see, I mean, it has more information, but just for the sake of this talk, let's just focus on these ones. As you can see, the last one is the HugeTLB entry, which means that work HugeTLB range will only call that indirect function. And the funny thing is that those functions share quite a lot of code with the other ones. It's just that sometimes we need to, it had to be rewritten that way because HugeTLB has its own way of doing things, and yeah, you know the story. So the first attempt, I sent. I got in touch with Peter Chu to help along. And last summer, I sent the first attempt of making HugeTLB go through the generic pagewalk. But it was some of the feedback I got that I saw myself is that the current API was pretty suboptimal to support HugeTLB as it is right now. So it has some constraints when batching, because for instance, HugeTLB can be mapped with contiguous PTs and contiguous PMDs as well, and making that work with the current API was, I mean, I made it work, but it was awful. It was quite not really nice to see. And also there were some complaints that the current API with all those in there calls was something that could be improved. And while reviewing, David Hildenbrand from Red Hat proposed a new API which will get rid of the indirect calls. It will just be like a normal page walk. It will handle batching and logging internally, so the callers wouldn't have to do it, as it's currently the case, at least for logging. And it will return a stack filled with information that the caller could use in order to make sense of, okay, what was found in that range and what can I do with that. So to sum it up, you will pass a BMA. So this is kind of a prototype still. So you will pass a BMA and the types where you are interested in, because some functions, for instance, maps, NUMA maps from proc file system, are only interested in folios, in present folios, and maps in swap entries as well. But the other stuff, they don't really care that much. So you will opt in which types I want to get returned. And as I said, it will manage locking and batching internally. For instance, contiguous PTs, PMDs, and for contiguous swap entries as well. And it will keep going till reaching the end of the BMA, returning all the types you opt in along the way. So that's kind of the idea. These are the possible types it will return. The first one is when we're just done, and the types you want to opt in. So currently we have the folio markers, PFN, swap, migration entries, device for device exclusive, and so on, and hardware poison entries. And more or less, very summarized, the workflow will be on the right. So you specify the flags you want. You call PT range will start, and then you keep going until you reach the end. And then you call PT range wall done, which will unlock all the possible logs that are still locked. So, for instance, that's the on the left side. Also, living stuff will be the current proc pits maps file. So, as you can see, I pick all types, and then I opt out known PFN markers, because SMAPs is not really interested in those ones. It's only interested in the folios and in swap to account for the swap case. And it's pretty straightforward. You just switch the type and do stuff. And on the right side is the structure that it will return filled in. So has quite a few fields, and that's for the color to make sense of it if it needs to. This is not the final layout, but it's the layout I just found so far that provided enough data for at least all those users that I converted. There were some challenges when doing so, because HugeTLB has this particularity that everything is a PTE to it, although it might be mapped at some other levels, but it treats it as a PTE, which means that a generic page walk wouldn't know how to make sense of some huge TLB pages because it's missing some infrastructure. For instance, we don't have a way to check whether a PUD entry is a swap entry, which we need for those special swap entries, and that might be hardware poison entries, migration entries, and I think there was a third one. I don't remember now. Yeah, special PFN entries as well. So we don't have this infrastructure. We also don't have markers for PUD and PMD levels. Currently, the upstream only has for PT levels. That's because markers are not supposed to be split. So, but we need those for HugeTLB because HugeTLB can have markers when you poison a HugeTLB page with user fault. So, and then you have the thing about contiguous PMDs. So currently upstream, we have this folio PTE batch where we can batch contiguous PTE entries. But we don't have the counterpart for PMD, so I had to also add that piece of the code. And all of this is already done. It's working, but it's code that we were missing in order to make HugeTLB more similar to the core. So at this LSFMM, I presented this, and the feedback was that the initial step will be to convert the users from task MMU, because those are mainly read-only users. That is maps, NUMA maps, and page map. And then there is a fourth user, the clear reference, which is tries to clear soft dirty bits and some other bits that is yet to be thought how it can be done. But it was agreed that we will start here, and once this was merged, we could figure out how to extend that to some other users. So I started the conversion, and I already have maps and NUMA maps done. And yeah, it was quite time consuming because I had to create a lot of tests for to exercise these special types like contiguous swap entries, hardware poison entries, migration entries, the markers, and so on. So I had to create all these tests. So I made sure that the new API could make sense of everything, and it will report correctly what it found. So I start converting maps, NUA maps in a. I kind of duplicated the interface, and then I ran the test for both using the old API and the new API, and just comparing the outcome. And I could see that the new API was just reporting properly as the old one. I've implemented this implementation. It has been only tested on x86 and ARM64 so far. I plan to test it on PowerPC in the upcoming weeks, and And yeah, maybe once this, I have to talk to David to see if the current shape of the code is it really it's ready. If it is, I might be able to try it out in other platforms. I don't expect to find surprises, but yeah, famous last words. Mm. The next steps will be I need to finish the conversion of the Procpit page map because that's the only only user left to be done. And then I as I said, I need to check whether I can try it out on more platforms, and I need to think what to do with the read write interface clear refs, how the current API can do that. But so far, that's I'm not concerned about that because we first need to really drill down the read only part. When that's done, I'll post it upstream for wider review because so far only David and I have been working on this. That's the current. So the current code sits there. Mhm. And there is with this thing this Power XX. So Power X 8 this PowerPC platform supports HugeTLB up to 8 MB, and it works because it maps two PMDs. Each of is 4 PMDs to directly when 1024 PTE contiguous entries. But the problem is that the size of the PTE isn't in the PTE itself, so but in the PMD, which means that if we are gonna making that work with a generic page walk will have its challenges if we don't have if we don't want to special case because we will have to special case anyways. So at the LSFMM was it was said that we either special case these internally in the API or we might drop support for HugeTLB on this platform because it's a pretty old one, and yeah, it's a pity that it creates those headaches. I'm not really that concerned because we can make it just work and we can hide it internally. So, but yeah, this is just a fun fact, and I think that's all. Thanks for attending. Not sure if you have questions. So.
Hello, I have a question. Which I understood that you changed or the question is, does this new API somehow reduce the number of logs that are held during the page walk? Or
Well, I mean, not really because you will have it. You will have to take the log for the page table you are currently looking. So if it's a PUD entry, you will have to take the log for the PUD entry and do stuff. If it's a PMD, so it doesn't reduce the logs because then you will also have to take the log for the BMA itself. So, but that was not really concerning. The concerning part was the indirect calls because, well, with the current API, when you're working all the page tables, you have to check if you have defined wait, yeah, if you that's not here now, if you have defined any of these entry points and then called indirectly and then return and then continue and then call indirectly, so it's really not that optimal. But
okay,
the logs itself, it's not really that of
thank you.
an issue.
So you expect all of the callbacks will be possible to eliminate, or some will have to stay for the clear refs or something like that?
So when I first implemented that with the old API, I had to go through all the callbacks. We have quite a few, and yet those were possible to, let's say, integrate HugeTLB into that. Uh, I don't foresee any real like impossible problem that we cannot work around. We will just have to see how we can do it, but it should be doable. Should be doable, and that's actually the long term goal, because we didn't really want just another API for another stuff, and we already have like 2 or 3 APIs for that matter. So we want this one to be able to replace the old one. Not sure how fast can we do that, but yeah. Then we don't have any more questions. Thanks a lot for attending.